Hope that I always worry if the sound's actually working. All right. Look, I did wear my shirt. You see how that's Gandalf, and then with an asymptote. You see that, right? And then anyone see the movie? You shall not pass. You ever see the movie? No. Lord of the Rings. Unfortunately, I also wore this for cat class, and they had a test today. You shall not pass. Anyway, they didn't like it. All right. So, but that's what happens. An asymptote usually is not crossed. But then you don't have to worry about it. That's going to be next year with different functions. It is true for these hyperbolas. The graph approaches those lines but doesn't cross. All you have to really care about is it creates the shape, which is different than a parabola. All right. Parabola is like they go like this and then curve up and then go up like that. Whereas a hyperbola curves and then it goes off to these asymptotes like a line. It's a little different shape, just so you know. But semantics, I really should have put center. What's the center? Let's all say it together, class. And by the way, I'm only going to bother you a little bit. I'm going to try to go about halfway through. Um, I do say it. You do. The rest is homework while you're eating turkey. Wait, how many people are turkey? Raise your hand. How many people are ham? Raise your hand. What? There's more hams than turkey? Right. Pizza. Oh, interesting. Anyone do something unique as well for Thanksgiving? Nothing? No? Some people like their ethnic food. Like, I don't know. Is that what you do? Nice. I do like that. I actually like that. We kind of did that back in the day. Sometimes as well. Alrighty then. So what's the center? Three, two, one, go. Did you hear them? All right. 1970s, 1980s education. All right. And then which way does this go? Up, down, or right, left? Which way does it go? Up, down, or right or left? Three and left. Three, two, one, go. Up, down, good axis. And then I can't. You have to know that these are the radii, 4 and 3. So you go to the center, 2 comma 0. You go 4 up, 3 4. Let's speed this up. 4 down. This is the stuff they should know because it's just like an ellipse. It's a fatter Mac that was helping somebody in tutoring today. And he told me this is ellipse information. Then I just started going and I accidentally was doing a hyperbola. And then I just realized, oh gosh, I'm doing hyperbola instead of ellipse. It was two little erase marks, and then the numbers were all still the same. Except I had to change C squared equals what's C squared equal in this one? A squared what? Plus B squared. But because it was an ellipse, I had to go back and refine C and do C squared equals A squared minus B squared. So that's why this is all very, very, very similar, like ellipses and hyperbolas. Instead of drawing an ellipse, though, we draw what? Three, two, one, go. What do we draw? A box, so that we can draw the asymptotes. And it does help me to draw the. Well, I've done this for a long time, so I do have tricks. But I still would just draw it real quick to just get all this other information. Like, what's the equation of this line? Well, I don't know if Lexi Samuels is doing equations of lines. She didn't tell me what she's doing. Probably should look into that, but she gets decent grades, so I kind of let her go. But I'm wondering what eighth grade is. I'm sure in eighth grade you did equations of lines, or at least graphing them. But let's not get out of what we're trying to get done here. Let's just finish this off, then we'll talk about the lines last. So those are vertices, and honestly, I went 4 up and 4 down. So literally, you could just add 4 to the center's y coordinate without graphing, and hopefully you're getting that. Now listen, I can write this one as 2 comma plus or minus 4. And I can, and I don't want to do that though if it was 2 comma 1. All right. You're not going to write 1 plus or minus 4. What's 1 plus 4? 5. What's 1 minus 4? -3. That one you're going to write as 5 and -3. When we have radicals, which I don't think we do for the foci. I think we have actual whole number, or I should say integers. When it's a radical, though, then you can tack on the plus minus radical thing. All right. And that's actually legit. So I hope you heard that. I take little half points off for someone writing 1 plus or minus 5. Why would you write that? 1 plus 5 is 6. 1 minus 5 is -4. So just keep that in mind. We're right to the foci, and I already have enough. I already know what I have to do for the asymptotes. I just really have to look at it. You already said it, so wrong, wrong, wrong. You already said it, so I won't make you say it again. This is because the foci have to be inside the bowls, so bigger than A. Wrong. I'm going too fast, and which is well, actually, I am trying to find C squared, so going too fast and making mistakes. Hey, what's 16 plus 9, which is easy? What's the square root of 25? And the foci go up and down. Now we're adding 5 to the center's y coordinate, and we can write that like that because it is 2 comma 5 and 2 comma negative 5. Those are the two coordinates. All right. And there's where it is. That's where 2 comma 5 and negative 5 land. There they are in the bowls, right where they belong, right where that cereal belongs. Okay, and then the asymptotes. Well, what did I tell you the asymptotes are? This was terrible. 5th hour. Rise over run, which is which axis first? Y-axis over x-axis. I was getting nothing out of my 5th hour. Nothing. Just looking at me like I'm some sort of clown. Right? So, but then where do both of these lines cross? Well, the center. So I did get to do this with you yesterday. Got a little bit of ahead of 5th hour with this. I just didn't complete the square with you personally, so we'll do that later. So if you want to write y minus 0, go ahead. Again, point slope form. I'm not reteaching lines. And the slopes are both a positive and a negative. Rise 4, run 3, or fall 4, run 3. So 4/3. And then it is crossing x minus 2 again. That's just point slope form. Don't try to compare this to what, but there is some similarities to the, how this all looks. It makes it pretty simple. You do not have to distribute 4/3 and negative 4/3 and get two separate y equals mx plus b's. But I really hope you do understand that. All right. I hope you do understand if I were going to have to find two of these lines, I would have to separate them into two separate ones and then distribute and then calculate them separately. We won't make you do that because of time. Do you understand? Yes. So we can write this as a plus minus 2 lines in one, 2 for 1 price kind of idea. So do understand that. Look at them for the love of dog. You could see that they have two different y-intercepts. So yes, there would be two different y equals mx plus b's if I actually solve for it. We do this with our CAT students if we still taught this, which we don't, which makes me sad. But anyway, you've heard me before complain about the new curriculum. We're losing some of our algebra, losing conic sections. So eccentricity is just B over A. By the way, I didn't mention this but of course, eccentricity for a hyperbola is greater than 1 because C is bigger than A. You have a bigger number over a smaller number. And I'm not going to get into it with that. I really like eccentricity with ellipses closer to 0. Closer to 0, it's almost a circle because then, look, I have an ellipse in here with the string. I ruined a pair of shorts. All right. Don't worry about it. All right. And then, so if I put this together and that was just the center, the string's called the radius. But then when I split this up into strings like this creates an elliptical scenario. So closer to 0, circular, closer to 1, more of an elliptical shape. Don't worry about what it does for these. Uh-oh, we have a question. B over A. C over A. All right. And then I have ones that I chose to do. You can graph those. Boom. What did we not do? We didn't what together? Complete the square. But it really is. This is why she was fine. She didn't need to see no video because it really is the same as with an ellipse. By the way, I did want to look at this though. Why is that not a circle? Why is that not a circle? Because there is a minus sign on a squared. So that's why that's not a circle. That's an ellipse. Same reasoning. But I like doing this one because we have a little bit more math going on with it. All right. So this is why we can do this. Sorry, this isn't a small section. Try not to write real big and sloppy. You can handle it. All right. I did two pages in one. So group the y's and go ahead and start the completing the square process. If you want to put that in parentheses, fine. Did I have to pull a number out in front? No, so this is good. Group the X's. Oh yeah, I got to pull out a number in front. So you can do this. You're in honors. You can get this done. You have to do it in 3 steps because of division at the end. All right, and then 12x becomes what times -4 equals +12? What's the answer? -3. Oh no, does anyone see the future? What are we going to have? Fractions. All right, and then I'm going to treat you like my cat students. Oh, I literally had a cat student today. I took their scientific and graphing calculator, input, say it. They just had to do the simplest input output. Somebody put a passive aggressive note on the test saying, "You took my scientific calculator away, so I can't do this." Period. Exclamation point. Angry face. You're gone. All right. And that's what I've been telling them all year long. Put your stinking calculator away and get your brain. That hurt. I don't care. I will have a mark here the rest of the day. Get your brain to think about numbers. Stop it. All right. You're a senior in high school. Anyway, good afternoon. Hey, what's that first blank? 3, 2, 1, go. 36. Do you hear these guys? And then, oh no. All right, here we go. If you put a decimal here, there's the what? Door. Because this makes me sick to my stomach. What is half of -3? Here, I'll start it. It's -3 what? Halves. I want to take this podium and toss it through the window. People that cannot handle that's -3 halves. And now the next thing is, what's -3 halves squared? What's -3 squared, class? And then what's 2 squared? 4. All right, so you guys are fine. This is why I'm sick that people make this like a calculus concept. It is not. It is not at all. And then one more thing. Oh, wait, what's this first blank over here? Is it really 36? Is it? Yes or no? It actually is. There's no multiplier. We know that's not 9/4, though. What is it actually? Here we go again. What's -4 times 9/4? 9, but what kind? Negative. So these are the things that my people like can't stop pushing buttons and copying screens still can't do. All right. And it's anyone? Acceptable. Okay, what's one? Did you? How many people knew that word? Unacceptable is what I was searching for there. What's the first one? Y plus what? 6 squared. And then I'm gonna leave this as plus -4. This is our third step. We're gonna have to do a division. So you can't get away with the ellipses and hyperbolas. You need that third step. All right, here we go. What multiplies to 9/4 and adds to -3? Hey, I have another question. What's half of -3? 3, 2, 1, go. What kind of 3 halves? Negative. That is the number. And it is true, -3 halves times -3 halves does multiply to be 9/4. -3 halves plus -3 halves is -6 halves, which is -3. All right. So we did just have a fresh test today. I did literally have that happen. That story I just told you. Oh, hundo. Now, what's the last thing we got to do? Divide. And then we'll clean it up how we write it. Oh, okay, y plus 6 squared over a hundo. So 10 up, 10 down. And then we'll turn this into a minus. Plus a negative is a minus, so we really see the hyperbolic format of a equation. Okay, how many times 4 go into a hundo? 25, so it's 25 on the bottom. Woo. All right, and then that equals what? You don't have to do anything else. You just had to complete the square. Other questions determine, items from there. So that's why she was fine, because all you have to do is pull out a negative instead of a positive number. It's just like doing an ellipse. All right. So I'm not needed for that. I love this one. It's because of that information about asymptotes. You got to watch about this and eccentricity. because the asymptote's slope and the eccentricity could be, let's see if you know the R word, reduced. And that's the problem. You're a fool if you don't what? Graph. At least think about it. Watch how quick I do this. 10 comma, well, there's 10. 10 comma 8, 10 comma negative 8. And those are the vertices. Which way is this going? Right, left, or up, down? This is how quick I can answer this question. Up, down, or right, left? Oh no! The only person I heard was right, left. How could that be? You know, this got to be like this. Okay, this is where the vertices, the vertexes, the two vertexes, which is said to be vertices. It's the only way that could go, right? I don't know how else to explain that. There is no other explanation. So, is it an x squared minus or a y squared minus? 3, 2, 1, go. Y. Okay, so some people need to work on this. I heard a couple people say X. This is what you need to get memorized. You know, I never did input output with these kind of things, checking or answer. No one really has time to do that. But it is true when I'm done with this, I could plug in 10 comma 8 and it'll be true with my equation. It will. All right. Okay, come on. What's the center then? Well, first of all, how far are these away from each other? All the way? How far are those away? 16. Well, that was kind of silly. So how far do I have to go to get to the center? 8. I mean, we could see that. I went 8 up, 8 down. So the center's right in the middle. So the center is 10 comma 0. So it's minus 0. If you want to write minus 0, just to make sure you feel good that you accounted for it in case you thought later, wait, I forgot something. It's fine. You wouldn't get marked wrong. And then I have another thing. What do I have? The radius of who? X or Y? Y. Okay. So what goes underneath here then? 3, 2, 1, go. 64. Now we're moving. You literally got 3 out of 4 parts just by graphing this. Wait a minute. There's something wrong. What did I tell you the slope is? The slope is rise over run, but it's y at axis radius over x-axis radius. So they're telling me the y-axis radius. Hold on a minute. Something doesn't mesh here. The y-axis, sorry, I didn't finish this. Rad over the x-axis rad radius is equal to plus or minus 2 over 1. But I just found out the y-axis radius is what? What did I just see? What's the y-axis radius? 8. So what truly is the x-axis radius? 4. It's simple math. It's simple math. So now I have the x-axis radius. So now tell me, what is this? 16. That's how simple this is. I told you. I know it's only the first day, but you got to be careful. Even with ellipses, eccentricity could be reduced. You need to check with other information and then unreduce. Really, that's what we did. We unreduced. Okay. So be careful on that and eccentricity. Oh, I'm not. You should be able to do some other ones there. You should be fine. I told you it's just like ellipses here. This might be the easiest question on the whole worksheets. I just wanted to make you understand that that's the box there. And you should know that because the vertices here, so that corner and that corner, ooh, look at that. That corner and that corner is where the end of the box happens. Easiest question on the worksheet. Let's take a look at this one. What did I just say about eccentricity? It could be what? Reduced. All right. Make sure you're finishing up on that test there too. I don't want to give you extra time there compared to the others. Okay, so boom. Okay, so 10, negative 2. Okay, so 10, negative 2, 10, and then 10, negative 18. We don't ask for much here. You don't do 1, 2, 3, 4, 5, all those tick marks. You just got to find out this. All right, and these are the vertices. By the way, which way is this going? I hope we get this right this time. 3, 2, 1, go. It's going up, down. So right away, I know it's a y squared minus an x squared. And I just have to fill in these parts. And you're going to get 3 out of 4 of them yet again. But then it's the same problem, just with a different thing given. But how far away are these two? Don't do some mathematics. Don't do like calculator. Wait, do I add or subtract? How far is it from -2 to -18? 16. This is common sense. All right. So if it's 16, how far do I have to go down to get to the center? 8 again. This is hilarious. Wait till you see what happens to this question. All right. So where is this center? Where's that at then? Obviously, it's at 10. 10 comma what if I went 8 down from -2? -10. It's simple counting. So the y coordinate goes with the y. That's minus a negative and then -10. I have 2 things. We probably give 1 point for the center. And I give you another point for this. What's this number right here? Again, 3, 2, 1, go. 64. Wait till you see the next number. But take a guess what the next number is. It is going to be 16, but it's because something weird happened here. What did I just say the x-axis radius is? This is c over a. What is really the x-axis radius, though? It's not 2, it's what? Say it again. No. What is the x-axis radius? I'm sorry, wrong. I agree. What is the y-axis radius? My bad, dogs. No one roofed. All right, my bad, dogs. What's the y-axis radius? 3, 2, 1, go. 8. So how does this happen? What is this then? What is this √5 really supposed to be then? Oh, someone said that hurts me on the inside. It's not 20. It's not 72. Wow. Where'd that one come from? 4 √5, which is not 20. Those cannot be multiplied together. Those cannot multiply together. That's how you cancel and reduce and get √5 over 2. 4 √5 over 8 is √5 over 2. So you better look at that and make sure you understand that, because I need to do that math in order to get this C value. I'm sorry, this B value. So the formula is kind of running out of room here. No, not really. Is this on a small page or is this on a big page? Big page, so you're good. C squared, just to remind you that it's plus, so I'll write it one more time. And then it's 4 √5. I really hope you understand that 4 √5 thing. Some people said 20, you're taking 4 and multiplying it by 5. Those can't be multiplied. All right. Or just look backwards. 4 √5 over 8 does reduce to √5 over 2. So I'm fine. Squared equals 8 squared, 64. We already know that. Plus b squared. And then what's 4 squared? What's 4 squared? 16. What's √5 squared? 5. What's 16 times 5? 80. 16 times 5. 5 times 10 is 50. 5 times 6 is 30. 50 plus 30. So mental math, instead of trusting your calculator all the time. When I subtract 64, what do you get? 16. Big yawn over there. All right. Good to go? You okay? No? How's that come? Good. It happened. All right. Okay. And then I actually did do these last two with the other, because they do have a little bit of a wrinkle in each one of them. Very similar, but with just one minor wrinkle. Again, I love this worksheet because you should have saw Fasola's worksheet. I saw it in tutoring today. She had nothing but fractions everywhere. Fractional center, fractional focus. She's really hammering down on understanding fractions without a calculator. I feel I've done you a disservice. I should have been more challenging. All right. But anyway, when I look at this, and I do mean that, it was awesome. And then we worked through it, and It really is not any harder than these numbers that we have here. You just got to think a little bit. So there's the center, 6 comma 2. Wait a minute. Now I have a focus. But do you see this? This is why I love this worksheet generator. What is that again? That's called the what? Just the 6 comma 2 is called the what? Center. So where am I going for the foci for this value? Am I going up, down, right, or left? They're only giving me one focus. Where am I going? I'm going down. All right. So, all right. I know you're going to hate this, but 3 squared is 9. 9 times 13 is 90 plus 27. 9 times 10, 9 times 3. So that's 117. This is equal to the square root of 117. What's the square root of 121? 11. So I would know I'd have to go, I'm not doing it, but I would know I'd have to go quite a bit down, like almost 11 spaces to get that focus. So which way is this hyperbola going? Is it right, left, or is it up, down? It's up, down because I'd have to have some U comfortably covering this piece of cereal like a bowl. Aw, right? Cereal bowl table. The other one's up here, 11 point something. They just gave us one of the two. All right. And that's all I need to know, that this goes down and up. So yet again, I'm obsessed with these today. The ones that I picked, it's a y squared minus an x squared again. Don't get a lot of change on that. I have the center. So this is simple. Y minus 2, x minus 6. That's easy. They gave me that. They didn't give me much more though. All right, so now I'm stuck. How do I get these values? Well, first of all, what is this thing called? What letter is that? What letter is that? A, B, or C is what I'm asking. 3, 2, 1, go. Everyone should be saying what letter? C. Focus, foci are C values. And again, that's why I make it X marks the spot. All the foci have always been X's. All right. All right. So now, wait a minute. What is eccentricity? What letter over what letter? C over A. We got something wrong here. They're saying C is 3 root 13, but it says it's root 13 there. Why? It's reduced. Are you done? Go ahead and bring it up here while we're doing this. So this means this equals, I'm sticking this right here. This is 3 root 13. What does that mean the denominator becomes? 6. It's simple multiply top and bottom like getting a common denominator. So A is actually 6. So what goes under here? 36. 36 goes here. And now I do need my formula, right? Yeah, I'm just trying to see if there's any. I need the b squared, so I need my formula. 3 root 13 squared, c squared equals a squared, 36 minus b squared. I hope you heard me when I did this little mental math, but maybe not. What's 3 squared? 9. What's root 13 squared? 13. What's 9 times 13? It's 9 times 10 plus 9 times 3. 9 times 10 is 90. 9 times 3 is 27. That's 117. 117 equals 36 minus b squared. Wrong. What did I do wrong? It should be plus. I screwed up. I knew something was wrong because wait, I'm going to get a negative b squared, which can't happen. Hey, do you know what 117 minus 36 is? A number. Did you just say a number? I love it. You are right. Ben, right now you are on fire. En fuego. No, it means a good. No, you're okay. All right. You never heard of that statement? Can't even hope to contain them. Like yeah. All right. You made a video. All right. See the screen. Last one. This one's faster than the last one. I think it actually reveals everything I need on this one. I'm a liar and a bum. Never mind. It doesn't. Okay. Finally. 6 negative 3. So what do I do? 6 negative 3. Oh, geez. And then 16. So 6, -3. And then here's 16, -3. Notice how I'm being kind of like, real cheap on my graphing because you just got to know where everything is in relation to each other. And those are called the what? Or that's called a what? Vertex. But remember, this is the center and that's of one vertex. So what is this? First of all, how far is it from 6 to 16? 10. Is that A? Or do I have to take half of that? Or do I have to double it? Is it half or double? It's one of the three choices. 3, 2, 1, go. It is. That is your A value. That's the distance from the vertex to one of the one vertex. So I already have A. All right. You got to understand that from this given information. Wait a minute. A is supposed to be 10. So what does that mean this top is then? Now we got it. En fuego over there. 5√5. That's what C is. And by the way, I already have my centers. And then which way does this go? Sorry, I didn't say that yet. Is it right, left, or is it up, down? Finally, all right, our first right lefter of the day. So it's x squared minus y squared. Come on, these are vertices. So the graph has to go like this. I missed. I don't care. X minus 6, y plus 3, and I already have 10 squared. I already have 3 things just by graphing this. 3. All right. Now I do have to do the thing. If you don't put equals 1, what's going to happen to you? You're gone for a half point. You're gone. Got to be an equation. I feel like that's like laziness. All right. 5√5. We'll get this done quick because it's same old, same old. 10 squared, hundo, minus b squared. Hey, everybody, what's 5 squared? 25. What's √5 squared? What's 5 25s? What's 5 quarters? 125. Right. 125 cents. That's what's wrong? That's exactly what I said. Okay. Huh? I said 5 quarters. He's throwing me off. All right. What's b squared? Are you okay back there? Someone's holding their head together like, I can't handle this anymore. 25. We're done. Let's end this. Happy Thanksgiving.